All right, we are live. What are we looking at? So, Oxide Computer seems to have just raised their Series B at $100 million. So, let's look into that. Tell me about Oxide Computer. All right. And while Grok goes into deep thinking, let's see. Oxide Computer Company. I think this is it. All right, 23.7. Oxide Computer slash bio. And let's look into this. Blue Sky. Okay, you have Blue Sky or LinkedIn. Mastodon. Latest from Oxide is Adventures in Data Corruption. On the Metal. Oxide and Friends Remote Access Contact. All right. Announcing general availability of the world's first commercial cloud computer. Okay. The cloud computer. Let's see. Oh, still thinking. All right. This is from 2023. Okay. Today we are announcing the general availability of the world's first commercial cloud computer along with our 44 million Series A financing. From the outset, Oxide and I outlined in my 2020 Stanford talk, we have had three core beliefs as a company. Cloud computing is the future of all computing infrastructure. The computer that cloud computing has become so real. I think it's so interesting. Okay, let's close the window first. It's so interesting how just like 4 years ago, cloud computing was a big thing, and now cloud computing has just become the standard. This is the standard. Now everything is going to happen over cloud computing, and as we have now, the conversation is about building more data centers around the world. Meta is doing their Manhattan-size project. OpenAI with the Stargate. Nvidia is supplying the chips. Tesla or Xia is doing the Colossus. So now data center is the thing that everybody's working on, and cloud computing has become the standard technology. It is the standard now. How are all these data centers going to be used? They are going to be around the world, and people are going to be able to access that using cloud computing. All right. So what's the bet over here? Cloud computing is the future of all computing infrastructure. The computer that runs the cloud should be able to be purchased and not merely rented. Okay. Huh. The computer that runs the cloud should be able to be purchased and not merely rented. Building a cloud computer necessitates a rack level approach and the co-design of both hardware and software. Of these beliefs, the first is not at all controversial. The agility, flexibility, and scalability of cloud computing have been indisputably essential for many of the services that we depend on in the modern economy, right? The degree that the second belief is controversial, however, depends on who you are. I actually don't know if it's controversial. I'm just like not sure what are the benefits of that. Why do we need that? For those that are already running, by the way, just quick story. Yesterday we went to Ethereum's 10-year anniversary at Dapper Labs office. That was amazing. Dapper Labs did some amazing work back in the NFT heyday. They were behind, were they behind CryptoKitties? I'm not sure, I forgot. But they were one of the big stars of Vancouver in crypto space. And yesterday we celebrated the Ethereum 10-year anniversary. That was amazing. I met a lot of old friends over there, old crypto friends over there. That felt amazing. Okay, back. For those that are already running on premises due to security, regulatory, economic, or latency reason, it is self-evident that computers should be able to be purchased and not merely rented, but to others. This has been more of a revelation. Since we started Oxide, we have found more and more people realize that the rental-only model for the cloud is not sustainable. Friends love to tag us on links to VC think pieces, CTO rants, or analyst reports on industry trends. And we love people thinking of us, of course, even when being tagged for the dozenth time. But the only surprise is how surprising it continues to be for some folks. The third belief, the development of a cloud computer necessitates rack scale design of both hardware and software, may seem iconoclastic to those who think only in terms of software, but it is, in fact, not controversial among technologists, as computing pioneer Alan Kay famously observed. People who are really serious about software should make their own hardware. Steve Jobs. This is especially true in cloud computing, where the large public cloud companies have long ago come to the conclusion that they needed to be designing their own holistic systems. But if this isn't controversial, why hasn't there been a cloud computer before Oxide? because it's big. To meaningfully build a cloud computer, one must break out of the shackles of the 1U or 2U server and really think about the rack as the unit of design. Second, it hasn't been done because it's hard. Co-designing hardware and software that spans compute, networking, and storage requires building an extraordinary team across disparate disciplines, coupling deep expertise with a strong sense of versatility, teamwork, and empathy. And the team isn't enough by itself, it also needs courage, resilience, and especially time. So the biggest question then, question when we set out was not, is the market there? Or is this the right way to do it? But rather, could we pull this off, pulling it off? We have indeed pulled it off, and it's been a wild ride. Let's first get a quick summary. Like, we're kind of like deep into the Series A announcement right now. Hardware and software start to focus on revolutionizing on-premise cloud computing by delivering rack scale systems that mimic the efficiency, programmability, and elasticity of public cloud infrastructure, but within customers' own data centers. Rack scale systems that mimic the efficiency, programmability, and elasticity of public cloud infrastructure, but within customers' own data centers. On-premise cloud computing. Okay. So it seems like it kind of makes sense. Like, okay, so for big companies, if you think on Meta was a big company, and Meta never had to. It seems like Meta never used AWS or Meta never used GCP or Azure, because Meta understood that, okay, we are the biggest company in the space. We are the biggest infrastructure. Like, we need a massive infrastructure, and nobody would understand our problems because nobody would build for us because we are the biggest. We are the first one to be facing this problem, and we are experiencing this problem at a massive scale. So we have to build our own solution. So they had to build their own on-premise cloud computing or on-premise data center. And then because they are building a consumer app, which has to have like your Instagram. If you like something, it has to show that like, there has to be no error. It's a consumer app. Instagram, Facebook, WhatsApp has to just work seamlessly. Your grandfather didn't have proper Wi-Fi, didn't have like really strong Wi-Fi, but still that message has to go. The message has to show in the group chat. That message shouldn't be deleted. It should be always there, no matter if I look at it 30 days later. So because they had to build a really good product, it's a consumer app, they were the biggest one to be experiencing this problem. Nobody would understand the problem and serve for them. So they had to do everything by themselves. So they had the incentive to make a really good on-premise data center, but not every company has that incentive to build a really good on-premise data center. So I think this is where this comes, that, okay, today, if you are a massive company, not today, let's say 5 years ago, if you were a massive company, you were building your own data centers, or your own on-premise data centers, but they were not highly efficient. So when the technology improved, and you had the option to move to AWS, you move to AWS. But still, you are working with some proprietary data. You don't want to rely on AWS. You don't want to give all that data to AWS or GCP or Azure. So then you're like, I still want my on-premise data structure for whatever reason. It's either regulation that your data shouldn't be sent to an AWS data center sitting in a different country, or simply the fact that your data is highly proprietary. It's like customers' health data or something, and it has to be on-premise. It has to be with you. So because of these certain reasons, you still are forced to use on-premise, but on-premise isn't that good. You are kind of a big, slow-moving company, so you didn't have a lot of incentive to make a highly efficient data center. And I think this is the problem they are solving, that they are making your on-premise data center as good as something that AWS would build. Because AWS has to serve the biggest, baddest companies, Netflix, everybody, Uber, Stripe, Figma, everybody. So they have really high efficiency, but you don't have high efficiency because you don't have that knowledge. So Oxide, I'm guessing, is bringing that knowledge or that kind of efficiency to on-premise data centers. All right, let's go. Founded in 2019 and headquartered in Emeryville, California. The company employs between 51 and 200 people and targets industries like government. Exactly. Government. I'm guessing the biggest customer would be government and banking. Right. Financial service basically means banking. I'm also guessing hospitals would be, I don't know why it doesn't say hospitals, but anyone who's dealing with customers' health data, They basically want on-premise data centers. On-premise data centers. Yes. Government, financial services, e-commerce, high-performance computing with notable high-performance computing. I don't know if that means hedge funds. With notable customers including Switch, Shopify, Lawrence, Livermore National Laboratory. Laboratory. Company was co-founded by Steve Tuck, Brian Cantrell, and Jesse. Brian is the CTO. Jesse Frizzell, Chief Product Officer, who bring extensive experience for companies like Dell, Sun Microsystems, Joint, and Apple. The motivation stems from foreseeing challenges in managing on-premise infrastructure, aiming to bridge the gap between hyperscale cloud innovations and traditional on-prem setups, where about 85% of global IT workloads still run. Very interesting. Okay. So even though we have hyperscale cloud innovations, so it seems like it makes sense. Hyperscale cloud innovations is serving the best startups in the world. But traditional on-prem setups is how the traditional world still works. And what is the traditional world? Traditional world is your bank. Traditional world is your government, and that's your hospital. That's your that's all the other IT companies and government departments and everything, which takes 85% of IT workload. That is crazy. That is crazy. What else? What else? Construction companies. Yeah. Okay. The team emphasizes end-to-end design accountability, eliminating vendor silos by co-designing hardware and software from the ground up. Vendor silos. So this would be the main problem, that what you're doing is you're taking an Android approach where you are basically buying products from 10 different vendors, and what they are doing is then, okay, let's assemble that in your data center. And that is leading to a lot of inefficiencies when different products have to work together with other different products, and they were never vertically integrated and build from the ground up together. Products and offerings. That's where the inefficiency comes from, when 10 different parts from 10 different vendors have to work together. You have to stitch them together. Oxide's flagship product is the Oxide Cloud Computer. Let's see if we can get a photo of this. A vertically integrated. Okay. Interesting. All the benefits of public cloud but on-prem. So that's interesting. But I don't know. Are we saying that no matter how successful cloud innovations have been, all the stated number over here is 85%, which is kind of crazy. Like pretty much we are using most of the stuff we are using in our daily life is kind of the high-tech companies. We are on Facebook, we are on Instagram, we are on WhatsApp, we are on TikTok, we are on Google Chrome, we are shopping on Amazon, we are for buying anything on Shopify, we are using Shopify. What else? Fang. Facebook, Amazon, Apple. We have Apple devices, but I don't think that counts. Netflix. Yes, we are watching Netflix, and then we're using Google. But it seems like these tech companies still kind of have just 15% of the total IT workloads, and most of the stuff is happening. 85% of the stuff is happening on-prem and like traditional, via traditional companies, which kind of makes sense. I think mainly if you think about banks, I think banks is the one where most of the stuff is, banks and government kind of takes up most of that pie, let's say. But this is interesting. Okay. Oxide's flagship product is Oxide Cloud Computer, vertically integrated rack scale platform that arrives fully assembled and ready to deploy, no cables or assembly required, provides elastic compute, on-demand virtual machines with features like live migration, self-service networking, serial console access, distributed block storage, high-performance scalable storage with configurable IOPS snapshots, and support for mixed workloads, self-service networking, virtual private clouds with built-in routing, firewalls, and AT ensuring per-tenant isolation. The system, yeah, so what I was saying is like Oxide is betting that this 85% IT workload, which is happening on on-prem, isn't going to move to cloud providers. That's their bet. And they're going to replace the 85% market to Oxide, um, which is very interesting. Which is very interesting because I know Azure is already working. Microsoft is already working on making, on helping the on-prem industry. Sorry, on-prem, yeah, on helping the on-prem industry. And everybody's pretty much serving the on-prem industry as well because that is where the big money is at. Yes, you can work with startups like Netflix, you can work with startups like Figma and Stripe and everything, but the big money is with government and banks, and you want to serve them. You want to sign those contracts. The system is API-driven, compatible with tools like Terraform, and focuses on multi-tenancy, security, and observability through a unified control plane. It's designed for rapid deployment, unboxed provisioning in about 2 hours, and offers significant efficiency gains such as 55% better power usage and 12x improved cooling compared to traditional setups. This makes sense. So this is the efficiency they are beating when you are when you Android approach versus Apple approach. Pricing eliminates licenses or subscriptions for predictable economics, and it's suited for demanding workloads like AI. Technology and approach. Oxide rethinks the entire stack from printed circuit boards and microcontroller OS to platform software and switches using first principles design. Key element in there is their use of Rust programming language for safety and performance, which is even reflected in the company name. Oxide, Rust. Okay. Oxide, Rust. Huh. You rust because of oxygen. I don't know what that means. They need to explain that. A key element. Explain this. Explain, please. What does this mean? All right. Hardware is designed in-house in Ontario or Chippewa Falls, Wisconsin, with a USA country of origin designation. The software includes open source components available on GitHub. This integrated approach avoids a bit of pitfalls of commodity hardware, providing hyperscale-like features on-premise while prioritizing sustainability, developer velocity, and operational simplicity. Recent developments. Oxide began shipping its first commercial cloud computers in July 24, marking a milestone after years of development. Just yesterday, the company announced a $100 million Series B funding round led by USIT with participation from all existing investors. The funds will scale manufacturing, expand systems and operations capabilities, and broaden the product roadmap to position Oxide as a long-term player in transforming computing. On X, their recent activity centers on responding to congratulations for this funding, highlighting community support. Early rounds included 44 million Series A, bringing total funding to over 144. Disruptor in data center space, enabling enterprises to achieve cloud-like agility without relying on public providers. Very interesting. I don't know about Oxide before, but this seems really impressive. Build things from board designs, microcontroller operating system, platform enablement, software to switch, control plane. The entire stack, hardware and software, needed to be rethought from first principles to serve this market. What is Rust? Rust is modern systems programming language created by Mozilla and first released in 2015, designed to provide the high performance and low level control similar to languages like C or C++ for building operating systems, embedded software, or high efficiency hardware drivers, but with built-in safeguards to prevent common programming errors. Key benefits: safety and performance. Rust emphasizes memory safety and thread safety through its ownership model, borrow checker, and strict compile time rules. This prevents issues like null pointer dereferences, buffer overflows, databases, and use after free errors, which are major sources of bugs, crashes, and security vulnerabilities in other languages. Unlike languages with garbage collection, Java or Python, Rust achieves this without runtime overhead, making it safe without sacrificing speed. Compiles to native machine code, offering efficiency comparable to C++ with features like zero-cost abstractions and fine-grained control over resources. This makes it ideal for performance-critical applications such as Oxide's hardware software stack for data centers. First principles design philosophy, where they build everything in-house to ensure reliability, security, and efficiency in their rack-scale computers. They minimize risk in complex distributed systems that handle sensitive workloads like AI and financial services. Okay, the name Oxide is playful pun tying directly to rust. In chemistry and material science, rust refers to the reddish brown corrosion that forms on iron when it reacts with oxygen and moisture, scientifically known as iron oxide. So oxide is essentially synonymous with rust in this everyday sense. Okay, iron oxide and rust. By naming the company Oxide, the founders are nodding to their heavy reliance on the Rust programming language. It's witty, thematic choice that underscores their commitment to Rust's principle, just as Rust forms a protective layer on metal to prevent further corrosion, adding safety. The language provides protective mechanisms without degrading performance. Protective mechanisms without degrading performance. This branding reinforces their tech-savvy, innovative identity in the hardware software space. This is very interesting. Very interesting. You would think like Rust is actually damaging the product, but what is happening is Rust is creating a protective layer to prevent further corrosion. That is interesting. Let's go to this thing. All right, pulling it off. We have indeed pulled it off, and it's been a wild ride while we have talked about the trek quite a bit on a podcast. Oxide and Friends. Specifically, Steve and I recently answered questions about the rack. General availability is a good opportunity to reflect on some of the first impressions that Oxide Cloud Computer has made upon those who have seen it. For all the boxes. Traditional rack and stack approach starts with sea of boxes arriving with servers, racks, cabling. This amounts to a literal kit car approach, and it starts with tedious, dusty deboxing. But the Oxide rack ships with everything installed and comes in just one box. A crate that is its own feat of engineering. All of this serves to dramatically reduce the latency from equipment arrival to power on and first provision, from weeks and months to days or even hours. Is it on? We knew at the outset that rack level design would afford us the ability to change the geometry of compute sleds, that we would get higher density in the rack by trading horizontal real estate for vertical. We knew too that we were choosing to use 80mm fans for the ability to move more air much more efficiently, so much so that we leveraged our approach to the supply chain to partner with Sanyo Denki, our fan provider, to lower the minimum speed of the fans from 5k RPM to 2k RPM that we needed. But adding it up, the Oxide rack has a surprising aesthetic attribute. It is whisper quiet. To those accustomed to screaming servers, this is so unexpected that when... interesting. So what do they do? Minimum speed of fans lower. Okay. Interesting. So they have fans for cooling, and they reduce the minimum speed. They reduce the minimum speed from 5k to 2k RPM, and now it's quiet. Okay. This is so unexpected that when we were getting FCC compliance, the engineer running the test sheepishly asked us if we were sure the rack was on when it was dissipating 15 kilowatt. That the rack is quiet wasn't really deliberate, and we are frankly much more interested in the often hidden power draw that blaring fan noise represents. But it does viscerally embody much of the Oxide differentiation with respect to both rack level design and approach to the supply chain. Where are the cables? Anyone accustomed to the data center will know the missing mass of coal aisle cabling that one typically sees at the front of a rack. That's true, okay. But moving to the back of the rack reveals only a DC bus bar and a tight cable back plane. This represents one of the bigger bets we made. We blind mated networking. This was mechanically tricky, but the payoff is huge. Capacity can be added to the Oxide cloud computer simply by snapping in a new compute sled. Nothing to be cabled whatsoever. This is a domain in which we have leapfrogged the hyperscalers who, for their own legacy reasons, don't do it this way. This can be jarring to veteran technologists, as one exclaimed upon seeing the rack last week. I'm both surprised and delighted. Very profane variant of the sentiment. You did your own switch too when we first started this is very interesting. Like, yeah, rethinking how things work. Like, remove the cables, put them at the back, make it very simply like magnetic attachments. So you just have these sleds that you just insert and it starts working. You are now adding more compute. When we first started the company, one of our biggest technical quandaries, okay, was what to do about the switch. At some level, both paths seemed untenable. We knew from our own experience that integrating with third-party switches would lead to exactly the kind of integration pain for customers that we sought to alleviate, but it also seemed outrageously ambitious to do our own switch in addition to everything else we were doing. But as we have many times over the course of Oxide, we opted for the steeper path in the name of saving our customers grief, choosing to build our own switch. If it has to be said, getting it working isn't easy, and of course, building the switch is insufficient. We also needed to build our own networking software, to say nothing of the management network required to be able to manage compute sleds when they are powered off. Wait, that's part of it. It's one thing to say that all of the software that one needs to operate the cloud computer is built in, but it's another to actually see what the software includes. And for many, it's seeing the Oxide web console that really drives the message home. Yes, all of the software is included. And because the console implementation is built on the public API, everything that one can do in the console for the Oxide rack is also available via CLI and API. A concrete manifestation of our code as contract approach. And there's no separate licensing. One common source of pain for users of on-prem infrastructure has been license management, financial pain due to overpaying and underutilizing, and operational pain in the navigation of different license terms, different expiration dates, unpredictable dependencies, and uncertain vendor futures. From the beginning, we knew that we wanted to deliver a delightful integrated experience. We believe that cloud computers should come complete with all systems software built in and with no additional licensing to manage or to pay for. Bug fixes and new features are always only an update away and do not require multi-departmental discussion to determine value and budget. It's kind of crazy. It's kind of crazy when you have to pull something off like that. So much money goes behind it. You have to make sure that the vendors that from whom you're getting this very specific component, which is hard to make, and only these guys make it. You want to make sure that if you're getting it from them, they actually stay in business, so they keep producing it. Because what if they don't? And what if they don't update the software? Then it impacts your entire multi-million-dollar project. It's all open source. While the software is an essential part of the Oxide cloud computer, what we sell is in fact the computer. As a champion of open source, this allows Oxide a particularly straightforward open source strategy. Our software is all open, so you don't need to worry about hinky open core models or relicensing surprises. And from a user perspective, you are assured levels of transparency that you don't get in the public cloud, let alone the proprietary on-prem world. I think this is the best way to get people to bet on you, because if you're a startup and if you're in this hardware space, it's hard. People already think that you're going to die. Nobody's going to trust you. So by making the software open source, you are at least making people more confident that in future, if this doesn't work out, your hardware is good, but if this doesn't work out, at least we can go and update the software by ourselves. At least if other people are buying it, and that community can come together and update the software and keep updating the software, and we are not stuck with a proprietary software and this massive $1 million hardware, and the startup has just gone bankrupt. Very interesting. Okay, this is the website. All right. The cloud you own. On-demand elastic resources, on-prem economics and governance together for the very first time. Instance created. New instance. $55% more power efficient, unbox you provisioning in 2 hours, 0 licenses subscription. Cloud computing revolutionized the global economy. Whoa. Okay. Elastic compute, instance, Mumble. Oh wow. Okay, everything is hyperlinked. Mumble cassette, 4-star. On-demand virtual machines, high efficiency power design. Wow. Elastic storage, provision quota, elastic networking, TCP, ICMP, Accelerate developer velocity with a self-service environment. New disk created, disk create, da, 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 da. Provision and scale, just like the public cloud. Everything you can do in the console is available in the API and CLI. Leverage the tools you know, like SUSE, Rancher, Red Hat, OpenShift, Kubernetes, Terraform, OpenTofu, programmable networking, elastic compute, and storage. This is a beautiful color. On-demand virtual machines, distributed block storage, self-service networking, no assembly required, instant IT transformation, no more license management. Manage your cloud with a single unified interface. True multi-tenancy with secure, robust isolation between teams and organizations. Hyperscale power efficiency, Oxide. Alternative with rack level power design, unlock next generation workloads and more. The cloud you own right now. Actually, let's read this thing. So this looks interesting. Achieving cloud required a fundamentally new purpose-built computing architecture, an architecture born of necessity. The hyperscalers couldn't scale on commodity infrastructure, so they built their own. Until Oxide, cloud architecture remained exclusively in public cloud data centers, inaccessible to 85% of global IT workloads that run on-premise. Despite the vast need for an on-prem computing, companies face only a handful of commodity options preserved by market capture, not innovation. Despite the vast need of on-prem computing, companies face only a handful of commodity options preserved by market capture, not innovation. With disparate components that the end users left to design, integrate, operate, and support, little automation, and zero elasticity, capping speed and efficiency. Vendors pointing fingers with no real accountability even when teams need it most. Slow time to value and punitive subscription licensing. Server, network, storage. The cloud computer. That's why we built the Oxide cloud computer, a rack scale system built true to cloud architecture that you can own and operate in your data center. Our system delivers all the hardware and software you need to run your own cloud, designed together end-to-end across every layer, from the printed circuit board to the API endpoints. That's the only way to build cloud architecture. With elastic resources, full stack programmability, control plane, governed multi-tenancy, and rack scale power efficiency, API-driven unlocking developer velocity with on-demand resources, built for supportability and observability. Get the efficiency and speed of cloud in a system with predictable economics, zero licensing, unmatched security, and time to provision that's measured in hours, not days. Interesting product. Compute. On-demand virtual machines, 2 CPUs, RAM, distros, images, snapshots. Metrics and monitoring, project level resource. It's very interesting to create such a website when you're working with a highly technical product. You want to show everything, it's complicated. Your entire website is a mapping of your product. Oxide virtual private cloud. Self-service networking. Rack networking at a glance. DDM, hardware and software co-design, patch panel. What is this? Play. I've done some good work on the website. Storage. Events. Okay. November 12, 2025. KubeCon North America, beer and boards. Principles, yes, okay. Our mission, principles, and values are not mere corporate bromides, okay? They comprise the emotional, moral, ethical, and spiritual core of our company. They are the soul of Oxide. Our mission, kick butt, have fun, don't cheat, love our customers, and change computing forever. If this sounds familiar, it's because it's essentially Scott McNeely's Coda for Sun Microsystems. Kick butt, have fun, don't cheat, love our customers, and change computing forever. But we use this mission not because it happens to have been Sun's, but because it is ours. It is a concise expression of why we are here and how we operate. So, what does this mean exactly? Kick butt. We believe in working hard to deliver a kick butt product, experience, and company. We are by nature a competitive company, but we compete by offering a better alternative, not by denigrating or otherwise undercutting the competition. Have fun. We believe that work is most fulfilling when it is fun, and that a good sense of humor is essential for humility in the good times and endurance in the lean ones. Don't cheat. We believe in playing by the rules of the game, abiding by both their letter and their spirit. If we don't like the rules, we work openly and collaboratively to improve them. Love our customers. We recognize our customers take a risk on us, and we love them for it. We work to deliver products that they will love in turn. And if and when our products fall short, our love for our customers trumps our own ego. Change computing forever. Computing is our shared passion. Our calling is to advance the state of the art, bringing those advances to the broadest possible audience. Our principles: integrity, honesty, decency. Competitor. We seek and tell the truth, even where those truths are painful or inconvenient. We abide by the spirit of the truth, not merely its letter. We do not hide falsehoods in language in it that is technically true or otherwise misleading. Principles are meaningless without the integrity to uphold them. We view our integrity as our single most important principle. We do not sacrifice our principles for expediency or comfort. Candor, courage. We are bold, willing to do things even if they are unconventional, difficult, scary, or otherwise unproven. We are not, however, foolhardy. Where we are contrarian, it comes not from mere desire to take a less traveled path, but from a deep and well-informed conviction. Unafraid of learning something new, be it an intimidating new technology, perplexing system behavior, or a novel customer use case. Diversity, empathy, humor, responsibility. Whoa, 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 whoa. Can you have these many values? Candor, courage, curiosity, diversity, empathy, humor, optimism, resilience, responsibility. Feel a duty to things larger than ourselves. We don't merely fulfill our obligations, but actually seek ways we can help. We balance our professional responsibilities with our personal and familial ones, and we honor those who do the same. Responsibility, rigor, teamwork, thriftiness, transparency, urgency, versatility. We have finite resources and limited time with which to achieve our mission. We must be focused in our approach, however immense the task at hand. Urgency should not be conflated with pace. It is important to move deliberately rather than hastily. Versatility. While we must naturally specialize, our bold mission also demands that any of us may need to apply ourselves in a new domain, and indeed that many of us will be doing this much of the time. Secrets are often corrosive, and that we work most effectively when we are aware of broader context. We err on the side of transparency and communication. Every Oxide employee should feel that there is a standing invitation to any meeting. At the same time, we are respectful of privacy. Personal issues should remain private. We must be disciplined and thorough in our approach. We insist on getting at the root of things and are unsatisfied to merely address the symptoms. Company, career, podcast, on the metal. Oxide and friends, on the metal. Nerdiest podcast on the face of the planet.
Garage. We are in the room we call the litter box. Adam, welcome to Litter Box. Happy to be here. Exactly. So, those of you who have On the Metal in your feed may be forgiven for a double take here. We are back at least for a moment. So, in a long time. So, if you were an On the Metal listener, you know when we started Oxide in 2019. God, it was so long ago now.
Interesting. Let's go to their feed over here. Okay. Happy to say that we have raised Series B, which was a wonderful excuse to work on this little featured blog header ASCII element with text trimming, responsive text sizing, and funky STF coins. Cool. Unsurprisingly, is a typography inspired by the capsize library. It trims the top and bottom space out of the title, then weakens so the leading and type size as multiple of grid cell height. Okay. Huge congrats. Glad to be supporting you all in a beautiful design. I'd forgive you for assuming that we merely integrate components fully designed and manufactured overseas, but that's how most computer companies work today. Whether you know that our system PCBs are designed in-house and laid down in Ontario. Chippewa Falls. Why does Oxide use Rust?
Hey, it's Brian from Oxide. I'm back with another FAQ Friday. Question we get from time to time is, why Rust? I know you at the Oxide Computer Company implement a lot of what you implement in the Rust programming language. Why Rust? And I was surprised that, I gotta tell you, I was a diagnosable C programmer for most of my career. And I would not have believed, my past self would not have believed, that my career would be so revolutionized by a programming language. But as I got into Rust, actually, I got into it thinking, if it's not Rust, I don't know what it's going to be. I have to go back to C. I was frustrated. I was frustrated with JS. I was frustrated with Go. I was looking for a language in which I could implement the systems that I wanted to implement. Operating systems, kernels, lower levels software, firmware, and so on. And as I went into Rust, it was with skepticism. But Rust very quickly won me over. It's an extraordinarily powerful language, and it brings these really modern, very powerful primitives in a package where you can actually generate a type fast artifact. It's not a garbage collection, which is very important. The actual artifacts themselves are fast, they're suitable for an operating system kernel. And when we started the company, I wrote a blog entry called Falling in Love with Rust, because it expressed exactly what I felt. I was falling in love with Rust. After coming to Oxide, I wrote a blog entry called Rust After the Honeymoon, where I reflected on all the little things that I have loved about Rust. I think one of the surprises about Oxide, when we started the company, we knew we were going to use Rust, we knew it was going to be important, but we didn't want to use it by fiat everywhere. We want to make sure we use it by tool for the job. I think one thing that's been surprising is the scope in which we use Rust. We use Rust all the way to the very, very bottom of the stack. Hubris, our Python 4 operating system, is all in Rust. That ain't the smallest thing that runs on it. Cortex M0 Plus. It's got 8K of RAM, 64K of ROM. That's smaller than the first computer that I had growing up in the 80s. It's crazy small. You can get an operating system with memory protection down to that size. Conversely, we also operate at the very top of the stack. And making available, you check out Dropshot, Progenitor, these things that we've generated to allow us to write our web services effectively in Rust. We also use it in our own internal IT is all in Rust. I actually find that I go to Rust instead of going to a shell script. We use Rust for just about everything outside. Not by fiat, but because so frequently it is the right tool for the job. So people wonder, and we have people come back and say, hey, do you use Rust at Oxide? It's like, well, it says right there on the Oxide Computer Company, very much tip the hat to Rust. And now 5 years in, we can report that it has actually had more benefits than we anticipated. Thanks, and see you next time. Hey, it's Brian from Oxide of that.
Interesting. Tech exec, an Oakland A's fan. Customers are clear. They need computer infrastructure that can verify and audit non-mystery code. They need computer infrastructure that they can verify and audit non-mystery code in proprietary firmware. When you can inspect every layer of infrastructure, you are not just buying servers, you're running a cohesive platform you can trust and verify. The gap between cloud and on-prem developer experience isn't just inconvenience, blocking innovation. When engineers fight infrastructure instead of building, everyone loses. Oxide delivers cloud-like self-service environments on-prem. Hyper-converged infrastructure. What if deploying new on-prem and cloud infrastructure only took an afternoon while with Oxide it does, a rack scale system arrives pre-assembled, tested, and ready to go. No oversubscription isn't just a technical decision, it's a philosophical one that helps you.
That I want to break down. On the CPU side, Oxide makes use of AMD's SMT, or simultaneous multithreading, which treats each physical CPU core as 2 logical CPU cores, and those logical CPU cores are mapped to virtual CPUs in your instances. On the RAM and disk side, those are just bytes all the way down, so your instances are free to use however much RAM and disk they need should it be available in Oxide. This approach helps prevent resource exhaustion. You can configure silo resource quotas to limit the amount of CPU, RAM, and disk available for use in your silo. The CPU and RAM for running instances count against a quota, and the disk for running more stock instances also count against a quota. This helps mitigate the noisy neighbor problem where one instance uses resources that another instance needs. In fact, you cannot start an instance that would otherwise exceed quotas. This also helps with capacity planning. In Oxide, the resource usage isn't bound to you. What you're actually using is what you're actually using. And if you need to change the number of resources you're using for an instance, you can do that. You can resize an instance without worrying about jumping up to some new resource size that costs more because you own the Oxide cloud computer. This enables teams to have honest conversations around capacity planning with data from Oxide to back it up. Oxide is hardware and software built from the ground up, and we we could choose to allow oversubscription of resources in the future, should there be a customer need or use case for it. But not oversubscribing resources allows us to limit complexity and focus on building a great product for you. If you've experienced resource exhaustion, capacity planning woes, or just had to balance cloud infrastructure provisioning with controlling costs, then Oxide is right for you. Oxide solves all of these problems and more, and allows you to write and provision your workloads on Oxide today.
Highly technical stuff. We didn't understand a thing over there. Oxide and friends. Okay.